The problem that we have to solve is related to 3 points. The first point is to predict when a customer will churn or become inactive with 2 or 3 months in advance. The second point is to determine the propensity to buy a certain category or product based on the history of this customer. And the third point is to predict what is the likelihood that the customer will buy a certain product after purchased another product. For this problem, the data you analyzed is transactional data over a period of 2 years. The data consists of 200,000 transactions, where we have the ID of the user, the product being purchased, and the date of the transaction. The first step we have to do with the data is to aggregate it and clean it in a proper way. After adding the socio-demographic data, we end up with 96 different variables. This graph shows an overview of our data and gives a snapshot of where the user is spending their money and how many transactions is occurring over this 2-year period. Then we address the problem of churn prediction. To address this problem, we have to use a classifier. In our case, we used random forest algorithms in order to separate the churners from non-churners. A random forest algorithm is a collection of decision trees. A decision tree is a set of branches where we separate the variables in terms of their capability to separate the 2 categories. In this case, churn and non-churn. On the right-hand corner, we see an example of a decision tree for the problem of the churn. We achieved a very good accuracy, with being able to predict when the customer will become inactive or eventually will churn the bank in the next period of 3 months with an accuracy of about 90%. The proper way to evaluate these predictions is by looking at the precision, recall, and area under ROC curve. This table presents the numbers for 2 different periods, September 2013 and December 2013. You can see here in this plot that we can extract the most relevant variables to explain the churn for this particular problem. For instance, the expenditure in the categories of fashion and moto are one of the most important to separate the 2 categories of churners and non-churners. We also applied a similar algorithm in order to predict how much the customer will spend in the next month. We see here in this plot that our algorithms can predict with a great accuracy how much each customer will spend in the future. Furthermore, we also ran a sensitivity analysis for this problem. In this graph, we see how much each variable influences the output. This plot is very useful in order to understand the output of the model in terms of this relationship to the input.